Okay, welcome to the first practice, on DeltaMath. This is going to show you an example of how to find the magnitude and direction of a vector. Of course, refer back to the old notes or what you used on that video to kind of follow along here. So, first of all, the problem says we have an initial point at -8, -5, and a terminal point at -4, -2. So if you're looking at that, here's -8, -5. Let me make sure I got it right there. Okay. And here's -4, -2. Got our 2 points. Okay. Remember, one of these is a start point, and one of them is an end point. So we just need to draw our vector here on DeltaMath. Hang on, there we go. Okay, and that's going to be our vector. Okay. Now, but remember in the notes earlier, I said that it doesn't really matter where you start and end as long as the vector actually maintains the magnitude and direction. So we're going to move it so that its tail is at the origin. That's what it says right here. So we can move it so the tail is at the origin. Watch this. Okay, I'm moving it here, and I'm moving it here. Okay, origin. Boom. Okay, so it's the same vector, but we just changed where it started and ended. And so it's a little more obvious, okay, as to what the components are, right? Our components are 4 and 3. Okay, so we scroll down here. I'm going to clear my board here real quick. And here we go. We have a component form. This is another word for numerical, right? Numerical. So I have 4 as my horizontal and 3 as my vertical. Okay. That should be fairly obvious. I have 4 right here and 3 right here. So this is what this module will help you do and how you figure it out. Next up is the magnitude. Okay. Remember, with magnitude, we had to do the Pythagorean theorem a little bit here. We have to set it up so that it's like easy to think about. We have 4 squared, which is our x, okay, and 3 squared, which is our y, and all of that is supposed to be the magnitude of our v squared, right? So we square root this, kill this, and let's figure it out real quick. 16 plus 9 equals this v part, and that's 25, right? So our magnitude of v should be 5. Okay. Something very important to note is that magnitude is never negative. Okay. So never worry about that extra case there where that happens. And so since we don't have a radical, we can ignore that radical button. We can just put our 5 right in there. Finally, we need to find the direction of v, the angle, right? So let's take a look at our angle here. Okay. We've got positive angle, quadrant 1. Okay. Let's remember which number refers to what again. Okay. It's opposite. Okay. And this one over here is adjacent. So we have to use our wonderful, wonderful inverse tangent. Let me make sure I have this. Inverse tangent of 3 over 4. And that should help us get our answer. Inverse tangent 3 divided by 4 should be a wonderful 36. Okay. Sorry about that. 36.8 something something. So we are just going to round it up to the nearest degree, like DeltaMath says. 37. Submit our answer. And bada bing, bada boom, there it is. Okay. If you want to look at their steps, you can try this on your own. Take a look at that in your own time. Okay. They have a lot of different things here, but for the most part, I just walked you through it. Okay. And that's when it's supposed to be done here. Finding magnitude and direction. Okay, welcome back to this is the same part of the video. Okay, I'm going to continue on here. This is talking about vector addition. Now, we did show you a bit of vector addition numerically, okay, on the notes. This is with graphically and numerically. So if we do it numerically here, we can take a look at our 2 components, okay, our 2 component forms, and just add the numbers. That stuff's easy because we're doing addition for forever now. Okay, that's stuff, easy stuff. But what may be harder to visualize is how it's actually happening with the visual form. Okay. Given vectors u equals 2, -6, that would be this one on the right, and v is -8, -3, that's this one on the left. Find the sum u plus v and write the result in component form. So for this problem, okay, we can actually use vectors tail to head. Okay, tail to head addition visually. That means I'm going to take either of my two vectors. I'm going to take this one on the right, and I just stick the tail and the head together. Okay. In this case, I'm going to stick the non-moving one's head to the moving one's tail. Okay. There it is. If you can actually visualize the line, okay, that comes of it, here it is, right there. Okay. So where do we end up? What is our total? Okay. What is our total vector movement here? Well, we're starting at 0, 0. That's easy enough. And down here we have -9 and looks like -6 to me. Okay. So we know that this should have the component form -9, -6. Let's double check it. Okay. If I take our 2, -6, and -8, -3. Oh, sorry, I reversed these. This should be our x, and this should be our y. So I should actually move these around. I knew something was off. That didn't match up with what I was thinking. There we go. That's a little better. So if we add up our components from the actual problem itself, right? We have 2 and -8. That makes -6. We have -6 and -3. That makes -9. You should see that these all match up. Okay, so that's how vector addition works visually. Okay, they basically just stick to each other, okay, to combine and make a total vector. And you can do this with any number of vectors, not just 2. So let's take a look at plugging these in. Should be -6, -9. And there we go. Nice, easy peasy, right? Easy peasy. And you can kind of see their visualization of the movement here. Okay. And you can do that the other way too. We could have moved this one out here and had the same thing happen, right? The beauty of vectors. Okay, and that's pretty much all you have to be prepared for today. Okay, on today's DeltaMath, or I guess this lesson is DeltaMath, not today's, sorry. This lesson is DeltaMath. Okay. We're basically just going through this, and if this is stuff that you remember from physics, this is stuff that comes pretty easily to you. Okay. Or if you're not sure why we're talking about it, okay, how this is going to be used, just remember that a vector is a segment, okay, something that can be represented with a segment that has magnitude and direction. Biggest two things about vectors. And that's all I got for it. So enjoy the rest of your weekend if you're watching this on the weekend. If you're watching this a little bit behind, then hopefully this helped you figure out the DeltaMath. I will see you all in class.